Begin on page 104. We'll take our look at the calendar. Today is March the 2nd. We're going to finish lesson 11. Remember, lesson 11 is what we did on Tuesday. And we talked about solving systems equations using two algebraic techniques. One of them was called the method of substitution, and the other one was called the method of elimination, or the addition-subtraction method. I will remind you at the start of today's class of those two methods. And then we're going to cover all of lesson 12, which you can see highlighted here as applications of systems. Applications means word problems. So we're going to be doing word problems today that result in systems of two linear equations in two unknowns. You'll see that we actually have 2 days of applications of systems. The harder applications problems are coming up on day 2. So today is going to be the easier kinds of problems, and the next class we'll talk about some percentage problems and some motion problems that are typically a little bit tougher, but hopefully we'll lay a good foundation for those today. Coming up not too long from now is our very first test. It is on March 14. I guess, what is that, a week from this coming Tuesday, 12 days from now. It's definitely not too early to start studying for that. Peer tutoring, Math Studio, my office hours, your classmates, lots of resources to help. That test is going to be on, you can see here, everything, lessons 1 through 13. It's almost a midterm. I don't want to call it a midterm. We won't quite be at the middle of the semester, but it's almost a midterm. Questions on the calendar? Okay, so just a couple of things about the quest that I just handed back before we jump into the new stuff. So you can see up on the board the median grade was an 87 and the high grade was 100. So the median, remember, means that half of you did higher than 87 and half of you did lower than 87. This is the middle grade of everybody that took this quest here. So again, there's lots of resources if you're not happy with the grade that you got on this quest and or the grade you got on our first quest. There's Math Studio, Peer Tutoring, me, each other. Lots of resources to take advantage of. Also wanted to say that yesterday I sent out something called early progress reports, which are required of all faculty members to send to any student who has less than a C-. And in a developmental class like this one, there is no D grade, so anything under 70% is less than C-, and I had to send some EPRs out yesterday. So if you got one of those, well, I mean, you would have gotten one if your current quest average is less than 70%. So that's not my way of saying I don't think you can pass this course. If you got one of those, it's my way of saying I have to send this to anybody whose average is less than 70% right now, okay? But there's still lots of time to improve your grade throughout the whole course of the semester. Okay, so the other thing I wanted to say about that was somebody asked if we could take a quick look at this problem. What number is this? 6D. Look, I think it's the very last question in the quest I handed back. Yeah, so we're looking for the equation of a line perpendicular to x equals -5 and passing through the point 4, -2. Right, that's what we're after. Okay, and so this one is just it's just a couple of steps, and we hardly write anything down except for the final answer. But here are the steps. As soon as I see the equation of a line that has just a single letter in it, like x equals or y equals, I know I'm in one of my special cases. This line we're talking about here is either vertical or horizontal. And I know that because it's not a y equals mx plus b. It's an x equals or a y equals. And you're supposed to just have memorized or be able to figure out or have written on your cheat sheet which one x equals a number is. Which one is it? X equals a number. It's vertical. Every vertical line has the equation x equals a number. And here I'm looking for a line that's perpendicular to this vertical line. What kind of a special line is perpendicular to a vertical line? Is a horizontal line, right? There's no, like it's not going up and down at all. It's just horizontal. And so really I'm after the equation of a horizontal line. And every horizontal line has a special equation. It's y equals some number. So my answer to this question is going to be y equals some number because it's horizontal. And all I need to figure out is how much y is equal to at this point. What is it? -2. So that's the answer to this question. So if you started off thinking y equals mx plus b, you probably got into trouble right away. Like, X equals Y equals, we just need to know vertical and horizontal are special. We're going to treat them completely separate from mx plus b. Is that okay? All right. Okay. So one other thing before we jump in here on page 104, I was asked to remind all of my students that the scholarship deadline for the GCC Foundation scholarships, we talked about this, right? A couple weeks ago. This deadline has been extended. And so I pull up GCC's homepage to show you. You can barely see it here because it's kind of grayed out, but right there on the main page is the link to the scholarships. And I pull up the page, and not only am I reminding you, but the webmaster is reminding us as well. This pop-up jumps up. You cannot possibly miss the fact that the scholarship deadline has been extended. It is tomorrow at midnight is the new deadline. It says over 100 scholarships totaling over $102,000. One simple application for almost all 100 scholarships. A couple of check boxes and a short personal statement. I think it's between 250 and 400 words. Seriously, you could bang it out in less than 10 minutes. Here is my guess. This is based on no actual data. I have no other information about this extension. But my guess is that this thing has been extended because not enough people have applied, and there are probably some scholarships that are not even going to be handed out because nobody has applied to them. And so even more reason for you to spend 10 minutes possibly grabbing part of that $102,000. Again, 10% to me, standard. I just think it's fair, right? Just being reasonable here. I think it's a really good idea to throw your name in the hat. Any questions about this? You go here, click the link. It gives you the step-by-step directions for how you apply, okay? Almost all 100 of these scholarships have the same application, and it's just a matter of you answer a few questions about yourself, are you female? Do you live in Franklin County? Are you returning to GCC next semester? Just some basic information questions. You write a personal statement. I think it's something like 250 to 400 words, and then you click all the different, and then it will automatically apply you to all of the scholarships for which you are eligible. I would not be eligible to any of the female scholarships, right? There are a couple of scholarships where you have to do a little bit more writing, you have to write something specific about a particular topic, explain, sort of why you think you'd be eligible for that scholarship in particular. But for the vast majority of them, it is a very simple application. Other questions on this? I did not email it to you, but if you just go to the GCC page, it is right there on the home page. Yeah. Go apply. Okay, so I think that's good. So we're going to jump in on page 104. There you go. And on page 104, there's this quick check problem, which normally I have you guys do individually. We're just going to do this one together to remind ourselves of the two methods we talked about last class for solving systems of equations. So here we go. Solve this system of equations, those two equations right there, by substitution and then by elimination. So we're going to do this same problem twice, two completely different ways, hopefully to get the same exact answer both times. Okay, first thing, let's, I know it says substitution first. Let's do the elimination method first. For the elimination method, the equations usually have x and y on one side just lined up very nicely, one on top of the other. So I'm just going to rewrite this first equation here by moving this 2x over to the other side by adding it to both sides. So if I add that 2x to both sides, it becomes a 2x. That y is positive at the moment, so I'm going to put a plus sign in there, and it's equal to 6. Everybody see that? So that's adding 2x to both sides of that first equation. I'll just copy it, make sure you see where this blue equation comes from. It's that first equation, but add 2x to both sides. And now I'm looking at the bottom two equations, the typed one and my blue one. And they look to me like the normal elimination method setup, where the x's are lined up above each other and the y's are lined up above each other, and after the equal sign, some numbers above each other. Okay, the goal for the addition or the elimination method is to make it so that when you add the two equations, either the x's cancel or the y's cancel. If I add these equations, I have negative 3x, they didn't cancel. If I add the second column here, I got 2y, they didn't cancel either. But actually, if I just take the opposite sign of everything in my blue equation, then that positive y will become a negative y to cancel with this one above. So I think that's what I'm going to do. We're going to negate everything in this first equation, in the blue equation here. So multiply everybody by -1. Negative 2x minus y equals -6. And then just so that it's right next to the green equation, I'm going to copy this black one as it is. Negative 5x plus y equals -4. So when we add these two equations up, how many x's do we have? -7x, right? What happens to the y's when I add? They cancel. That's how we built it. Equals, and then we add over here, -10. And the nice thing about that equation is that it has only one variable in it, right? All the other equations have both x and y. This one has just x. That's better. Divide both sides by -7. And don't forget, it's your obligation, if you have a fraction with two negatives in it, make them both positive. This is not simplified, not until you go to +10 over +7. Okay, so there's the value of x. We also still need to find the value of y. One technique for finding the y would be to go back all the way to the beginning and do exactly the same process, but instead of making it so that the y's cancel, do something different to make the x's cancel. So for example, just looking at the x's here and here, looking at the x's here and here, we could multiply the first equation. Well, what number do 2 and 5 both go into? Smallest number is 10, right? And so how could you turn that 5 there into a 10? Multiply by 2. So you multiply that first equation by 2. I'd probably keep it positive too. You're trying to turn the 2 into a 10 by multiplying by 5. So you multiply the first equation by 2, last equation by 5, -10x, +10x will cancel. In this case, it's actually easier just to go to this very first equation right here, because I know that x is 10/7. I could just plug that right into this first equation, and that's going to tell me what y is. So we're going to do that way. So we get from this equation at the top, y equals -2 times the x plus 6. And what did we discover x is? 10/7. So that goes right there, right? So that's just copying that first equation, but change the x into a 10/7. All right, and then we just have to practice our fraction arithmetic here. How do we multiply fractions? Is it diagonals or is it across? Straight across. And -2 is really -2 over 1. So I'll put that in there. So upstairs, -20, downstairs, 7, plus the 6. How do you add fractions? You need to build a common denominator, right? So the lowest common denominator here is going to be that 7. So we're going to change this by multiplying bottom by 7, and therefore we also have to multiply the top by 7, right? So we go -20 over 7 plus 42 over 7. There we go. And then you can add because they have the same denominator. So -20 plus 42, that's positive 22 over 7. There's your y. There's your x. Any questions on the elimination method? Okay, we're going to solve the same exact problem with a completely different technique. The other technique is substitution. Give it a shot. The very first step for the method of substitution is to solve one of the two original equations for either x or y. Makes no difference which one you pick, but sometimes one is easier than the others. In this case, the first equation is already solved for y. So the first step is already done for us. We've already got a y equals, which means that we can take that y equals right there and substitute it in to the other equation for y. So let's give this a shot. So this equation comes right over here. I'm copying the whole thing, negative 5x plus, leave a blank space, equals negative 4. So that second equation used to say negative 5x plus y, and all we're doing is changing y to what? Negative 2x plus 6, because after all, that's exactly what y is equal to according to the first equation. This is fine as it is. I'm going to suggest that anytime you do this substitution method, you put parentheses. Sometimes you won't need them, but sometimes you will. And if you need them and don't have them, you'll get the problem wrong. So probably safest just to put parentheses every time you substitute. Okay, how many variables in that equation? 1. That's better, right? Both equations over there had 2. This one's just got 1. Okay, so let's solve this. I've got negative 5x. That plus sign really doesn't have any impact on the parentheses, so I'm just going to copy without the parentheses. And that means negative 7x plus 6 is negative 4. Trying to solve for x, so that 6 needs to move to the other side. So we got negative 7x equals. So that 6 goes to the other side. So negative 10, right, when we subtract 6 from both sides. And then we divide by the negative 7. So negative 10 over negative 7, but again, that's not simplified. 2 negatives divided make a positive. 10 over 7. How does that compare to the answer we got before? Same, it better be the same. It's just a different technique, but it's still trying to find the same answer. So x equals 10/7. We're not going to do the y calculation again. It's the same calculation we did. You get 22/7. Okay, so 2 methods. First one we did was elimination. Second was substitution. It is true they solve exactly the same kinds of problems. It is also true that I'm going to force you to learn both of them. I'm going to give you on a test, solve this thing by substitution, solve this thing by elimination. Actually, more likely what I'll say is here are two different problems. Solve one with substitution and the other with elimination. You can pick which one you do, but I'm going to make sure that I test you on both. So don't just learn one. Jenna? Yes, cheat sheet on every test and every quest. Okay, so let's go back now a few pages, and we're going to jump in on this page here, 96, page 96. Okay, so here's our summary. In this lesson, we look at applications of systems of linear equations. These applications involve total value and investment problems. 2 kinds of problems we're going to tackle today. I know that some of us are not thrilled about word problems, right? I wasn't looking for a call to arms here. Yeah, all right, so some of us not thrilled with word problems, but I'm hopeful that with a little bit of practice, we actually don't mind these kinds of word problems too bad. It turns out they are very formulaic, meaning it's the same pattern every single time. And if we can just recognize this pattern by doing a few examples that we say, okay, hey, I can actually do these kinds of word problems. They're quite predictable. And so that might be helpful for some of us. All right, let's give this a shot. Number 1, 2 types of candy sell for $2.50 per pound and $4 per pound. A store clerk is trying to make a mixture worth $11.70, but with twice as much cheap candy as expensive candy. So imagine you got this big old jar, and you got the expensive candy in the one hand and the cheaper candy in the other hand, and you're just going to mix and match into this big jar, and you want the jar to be worth $11.70, right? Additionally, you want twice as much of the cheap stuff as the expensive stuff. So maybe like every time you put in, 1 of the expensive candies, you put in 2 of the cheap candies, And you just keep doing that, and the value of the jar keeps rising, and at some point, maybe, the value of the jar will be $11.70. We're trying to find out when that happens, okay? How much of the cheap stuff and how much of the expensive stuff. So first step is to define the variables. That's done for us here. C equals the number of pounds of the cheaper candy, C for cheap, and E equals the number of pounds of the expensive candy, all right? And then we're going to fill in this table. We're going to see this table many times over the next 2 classes. So we've got 2 rows here, cheaper candy and expensive candy, and then down below is the total. So let's start filling in. Number of items, a number of pounds in this case. What letter did we use for the number of pounds of the cheap stuff? C, right? So that goes right there. And what letter for the number of pounds of expensive stuff? E. And sometimes we're given the total. Are we given the total number of pounds of candy we're going to use or not? There might be another problem where it says you're going to get 20 pounds of candy altogether, and you just put a 20 in that bottom box. But in this case, we're not putting anything in there. It's just not given to us. The middle column is typically the easiest to fill in. Cost per item, how much cost per pound in this case? How much is the cheap stuff? $2.50, so put $2.50 there. And the expensive, $4. Cost per item total, that doesn't really even make sense. I mean, I guess you could think about like the average cost per pound for the whole jar, but it's not just right in the middle of $2.50 and $4 because there's more of one than the other. So we don't fill that guy in. And then the total value. All right, this one is supposed to be easy if we think about it for just a second. Suppose that I say that we use 2 pounds of the cheap stuff, okay? How much is the value of those 2 pounds of the cheap stuff? It's $5, yes? Because it's 2 pounds and it's $2.50 per pound. What are we doing with that number and that number to get the value of that candy? We're multiplying, right? I mean, it's so obvious we don't even think necessarily. You're just multiplying. 2 pounds times this $2.50, yeah? Okay, so what we're supposed to do here is multiply. So it's $2.50 times, but instead of 2 pounds, it's a variable. It's C, right? Whatever C is, goes right there. So 250C. And the expensive stuff, how much per pound? $4 times what represents the number of pounds? E. And that's it. And I will point out, not for the last time, that this final column here is created by multiplying together the first 2 columns. C times 250, E times 4, that goes in this last column. We're going to see that a bunch with these tables. Even as the context changes for the problem, this last column is going to be the product of the first 2 if we set things up right. Okay, total value of the entire jar, is that given to us? It is. What is it? $11.70. Okay, now we've got to come up with some equations. Let's give this a shot. First of all, it says twice as much cheap stuff as expensive stuff. We have to ask ourselves, does that statement have to do with the cost, or does that statement have to do with the amount? It has to do with the amount, right? It says nothing about the cost. It says literally you have twice as many pounds of one as you do of the other. So the equation we write down right here is not going to have 250 or 4 in it. Some people tend to just kind of merge the price info with the amount info, and they're really separate. Twice as much cheap as expensive. I'm going to write 2 equations down. One of them is right, and one of them is wrong. Think for a second. Which of those 2 equations correctly captures what I've circled in blue? Twice as much cheap stuff as expensive stuff. Is it E equals 2C, or is it C equals 2E? Got a couple of votes for C equals 2E. A couple of votes for the first one. And I'm going to say this is a place where the English language is not doing us any favors when we translate from the words into the symbols. Because it seems to me to say twice as much cheap. If I hear twice as much cheap, that feels like 2C. Twice as much cheap, right? Double C. That's not what this says. This says that the cheap candy is twice as big as the expensive candy, right? If you really think about what that's saying, it's saying you have double the cheap stuff as you do the expensive stuff. Which one is the smaller of the two numbers? Cheap or expensive? Expensive. You have some expensive stuff, and then you have twice as much cheap stuff. That's this equation over here, the second one. You have some expensive stuff, and the cheap stuff is double that. Like I said, sometimes the English language doesn't help us when we translate. What you can do if you are not sure, don't guess. Half the time you get it wrong. Just make up a number. Like suppose, for example, that, like the expensive stuff was 5 pounds. For sure, how much cheap candy do we have? Definitely have 10, right? Because you have twice as much of the cheap as the expensive, yes? And so if you try plugging in 5 right here for the E and 10 right here, is it equal? 5 is equal to double 10? But over here, 10 is the C, 2 times the 5. Is that true? It is. Don't guess. Pick a number. If you pick a number, you'll definitely get the right relationship. Okay, so one equation is right there, C equals 2 times E. The other equation you get from this last column right here. The total value is $11.70. That comes from some cheap stuff, the value of the cheap candy, plus the value of the expensive candy. So 250C, let's write this here, 250C plus 4E is equal to 1170. That's just reading the last column. And those are your two equations. Now, setting up these equations is only half the battle. It's a significant part. I mean, half is significant, but there's still the solving part, right? Solving these equations is something that looks an awful lot like what we did earlier today. You have a system of two equations. It's not X and Y, it's C and E. Right? And so you can solve it with substitution or elimination. We're not going to spend our time today doing that. You can check it out later if you want. There is the answer right here. It's 2.6 and 1.3. Try to get that later if you wish. Any questions on the setup here before we do one more problem together? Okay, let's move on to the next page. And we'll talk about a problem involving money. Okay, the amount of money that is deposited in a savings account is called the principal, and the money a person earns from the bank is called interest or interest income. If money is invested for 1 year, then the interest equals the principal times the rate. For example, suppose that we have $700 in the bank, and we leave it in there for 1 year, and the interest is 5%. What would we do with these numbers to calculate how much interest we get as a dollar amount? 700 times 0.05, yeah? Just take 5% of 700. 1 year just makes things nice. You just have to do it one time. Jeff did something really good here. He didn't say 5 times 700. What did he say? 0.05, right? Percentages always have to go to decimals. So this calculation here would give us 700 times 0.05. I guess that's 35 bucks. Can do that calculation. So that's how we calculate interest. Principal times the rate. All the problems we do will involve a 1 year, so that's it. Okay, number 3. Question? So we're not going to work on it later. Technically, there's a times t. Yeah. Yeah. Times however many years. So if it was a 3-year problem, then you'd multiply by 3, right? If you get $35 a year, 3 years, you just multiply by 3. But just to make our lives easier, all the problems we do are going to be 1 year. So times 1 is why it's okay for us. Yes. Yeah, everything will be 1 year. Okay. All right, number 3. Jerry invested a total of $2,000 in two different banks. The first bank pays 4% interest and the second bank pays 9% interest. His yearly income from the 9% interest, 9% investment is $37 more than his yearly income from the 4% investment. That's complicated. How much did he invest at each rate? All right, first step is to define some variables. There's a lot going on in there, but to define the variables is easy. Look at the question. The question is telling you what the variables should be. How much did he invest at each rate? That's what our two variables need to represent. So we're going to have a L and H for low and high interest rates. L is going to be the amount in dollars invested at the lower rate. What was that? 4%. And H is the amount in dollars invested at the higher rate, 9%. Okay? It's the amount invested, dollar amounts. Okay, here's a table. Got two rows again, low and high, and then there's a final row for total. And let's start filling in this table here. Okay, amount of money invested. This is a variable. What did we call it? L there. This is another variable here. H there. The total is given in this problem. How much is the total invested? $2,000. Okay. That's how much was invested in total. And in fact, for kicks, why don't we just write an equation right now before we fill in the rest of the table? L plus H equals 2,000. That's it, right? Maybe it's 501 and 1,500 in the other, or 701 and 1,300 in the other. But whatever it is, L plus H has to add up to 2,000. Okay, interest rate. This middle column is easy. What's the low interest rate? So that means we're writing 0.04. Always decimals in this table. Convert percentages to decimals every time. High interest rate, 0.09. Total interest rate is meaningless. Cross that off. Okay, let's think about the amount of interest income. Remember, in order to calculate the interest, we took the principal, the amount of money, and we multiplied it by the rate. The principal, the amount of money, is L for this first row. L dollars invested in that low interest rate. And the interest rate in this first row is 4%. What do we do with these two things to calculate the actual interest? We multiply them. It's the amount of money times the interest rate. And so right over here in this last column, we're going to put 0.04 times L. That's the principal times the interest. I've written it in reverse order, but that's okay. And the next row, 0.09 times H. To be clear, those two things in purple represent the amount of interest you got from each of your two different kinds of investments. It's not a percentage, it's a dollar amount. Maybe you got 50 bucks in the one and 80 bucks in the other. That's what we just wrote down. It's how much interest you got in dollars. Okay, were we given something about the total amount of interest we got from the two investments? There's a 37 more, but is that the total? No, we're not given the total. It would have to be really clear. It would have to say, altogether, you made $108 in interest. That's what would go there. But we don't have that information here, so it's blank. Again, this last column is the product of the first two columns, right? L times 0.04, H times 0.09. Which is kind of interesting to me because this interest problem is really different from the candy problem, and yet the format of the table allows us to, fill in this last column the same way by multiplying the previous two. Okay, we've got the one equation already. We need to come up with the other equation. This is the hardest part for this problem, is that second equation. Okay, here we go. I'm gonna get rid of this, and we're gonna highlight this. His yearly income from the 9% is $37 more than his yearly income from the 4%. Okay, we're gonna do this piece by piece. There's only one correct way to write this equation and a lot of ways to write it wrong. Okay, let's start here. The yearly income from the 9% investment. Let's stop right there. There's lots of colors here. Yearly income from 9% investment. That is one of the entries in this table, but it's only one. which of these entries that we filled in is the income, the interest from the 9% investment? It's this 0.09H. It's right there. That's the amount of interest. Okay, so that goes up here, 0.09H. Okay, next up is my favorite symbol in all of math. What is it? Equals. Next up, 37 more than. How do we translate that? Something plus 37. You could either do 37 plus, or some people feel like more than something, they like to have a blank and then a plus 37. Either way, that's the 37 more than. And then finally, the yearly income from the 4% investment is one of the entries in the table. It's the 0.04L. 0.04L. So one more time, the amount of money you got from the 9% interest is 37 more than the amount you got from the 4% interest. It's the only right way to write that equation. I'm hoping it's manageable when you go piece by piece. Take your time here. Okay, so we've got our two equations. There's that one there. There's this one we wrote first here in red, L plus H equals 2000. Again, they're typed up here. You solve them in either of the two ways we talked about earlier today, substitution or elimination. I don't need to do that now, but if you want to try it later, turns out 1100 and 900 are the answers. One pointer I can give you for this kind of equation, if you're not a big fan of decimals, you can get rid of the decimals in this second equation by doing something right off the bat. How do you move a decimal point one spot to the right? What can you do to the number? It's multiplied by 10, right? Multiplying by 10, we know moves the decimal point one spot to the right. I need this decimal point to move twice to the right, so multiply by 100. So you can write this just as a kind of a pointer for later. You'll definitely have percentage problems, so you're welcome to do this technique if you like it. 100 times everything. It moves the decimal place 2 to the right, so the left-hand side becomes 9H equals, the 37 gets multiplied by 100. What does it become? 3700 plus, and then 2 spots to the right, 4L. So if you prefer that equation to the original, because it has no decimal points in it, you can just right off the bat multiply by 100. Okay, so here's the plan for the rest of our class. We've got a little over an hour. I know that we didn't have time to finish the activities last time. We just barely got them started. There were some problems about fruit. I think it was like apples and oranges and calories in them or something. I actually don't even need you to go back and do those, because the stuff that you were doing back there is embedded inside of these problems that we're doing here today. So I promise you will get practice with substitution and elimination by doing them with these in context problems. So the directions are a little bit unusual. There's a step-by-step guide here you can take a look at later. That's just there for your reference. But the directions here for the activities are unusual. Normally you would just do the first problem until you completed it, and then you would do the second problem. That is not what I want you to do here. What I want you to do is just write the equations. Just write the equations, and then move on to the next problem. I think there are 5 or 6 problems here in the activity. I don't want you to do number 1 completely. I want you to do number 1 only until you get to the spot where you wrote 2 equations like we did for the candy and the bank problem, and then move on to the next problem in the activities. So you're going to just set up with equations only all 6. Then you're going to go back to the first one and start solving and see if you can solve all 6. Also notice that I've given you some blank charts, but they're blank. So you're going to have to think carefully about what to fill in the column labels with and the row labels with. Raise the flag if I can help.